Good morning, students. Today we discuss about the moving coil instruments. First of all, we discussed about permanent magnet moving coil, and the part of the PMMC. We will elaborate the construction and working principle of the PMMC. The moving coil instruments are used to measure the direct current quantities like voltages and currents. They work based on the principle that a current carrying conductor placed in a magnetic field experiences a force. Coming to the construction of the PMMC instrument, it has a permanent magnet shoes and a rectangular coil. Whenever you have to see in the diagram, large number of turns wound on a light aluminum or copper former. So this iron aluminum former core is provided inside the former to provide an easy path for the magnetic lines of force. So coming to this diagram, here in the PMMC instruments having the north permanent magnet is bar is there, one north pole and south pole. In between the north pole and south pole, we have to insert a one soft iron core. Along with the soft iron core, we have a spindle, and that spindle connected to the upper control spring and lower control spring. This inbuilt with the one pointer is there in a total arrangement of PMMC instrument. In this PMMC instrument, the coil is mounted on a spindle. The springs are used to supply currents to the moving coil iron. Whenever the current is supplied, automatically the pointer will move from the upward or downward directions. The pointer is provided on the spindle to indicate the magnitude of quantity being measured. There are different torques are available into this PMMC instrument. These are deflecting torque, controlling torque, and damping torque. Coming to the deflecting torque is provided by the force acting on the coil when current flow through it. So see here, the current flowing through the control springs, whenever they are given to the power supply to the control springs, the current flowing to this one, they are provided to the force acting on the coil when current flow through it. The controlling torque is provided by the springs provided on the spindle. And finally, the damping torque is provided by eddy current induced in the iron core of the moving coil. The major part working principle of the PMMC instrument is when operating current flows through the coil, it produces a magnetic flux. When current flowing into that particular coil, automatically it produces the magnetic flux. The direction of magnetic flux depends upon the direction of current flowing through the coil. The same direction, the magnetic flux depends upon the direction of the current flowing through the coil. The direction of force acting on a moving coil and hence direction of movement of coil depends on the direction of current through the coil. These instruments can be used for measurement of DC currents only. Measurement of DC current only. The major advantage of PMMC instrument is it can be utilized to the scale of this instrument is uniform. Whenever you have to use this PMMC instrument, the pointer scale is from 0 to 100 or 0 to 50. It is uniformly divided into different space. And second, coming to these are the accurate and reliable. Whenever you have to use to the permanent magnetic moving coil instruments, it gives the results, reliable results as well as the accurate is more. And third one is eddy current damping is quite effective. When the damping torque is provided by eddy currents, it is be effective quite in the PMMC instrument. Fourth one, there is no effect of stray magnetic field as it has a strong permanent magnet. In the PMMC instrument, we are using into strong permanent magnet bar. In this, affected by the south pole and north pole, there is no effect. A stray magnetic field. Why? Because both opposite poles are reflected. Then only we don't have any magnetic field stored in between the two north pole and south pole. And the final advantage of these instruments are it requires low driving power. compared to other instruments, the PMMC requires very minimal power to run the instrument, and their power consumption is very low. These are the main advantages of whenever you have to use to the PMMC instrument. Basically there are two drawbacks involved in PMMC instruments. These instruments can operate DC supply only. Permanently, already we have explained, it measures only DC current. It operates only DC supply. The major drawback in this PMMC instruments. These are costlier than moving iron instruments. Permanent magnet moving coil instrument, moving iron instruments, they're very costly when compared to the previous ones. Okay. Next, moving iron instrument. One of the most accurate instrument used for both AC and DC. Previously, we are only for the PMMC measured only DC. But from the coming to the moving iron instruments, these only can measure both AC and DC measurements in moving iron instrument. There are two types of moving iron instruments, attractive type and repulsion type. The attractive type coil is flat. Whenever you have to see the diagram, the attraction type of the moving iron instrument, the coil is very flat and has a narrow slot like opening. Narrow slot like opening. The moving iron is a flat disc. Here, the move D, whenever you have to see the diagram, the term indicates D is a flat disk or a sector eccentrically mounted onto the particular balancing weights. When a current flows this coil, a magnetic field produced and the moving iron moves from the weaker field outside the coil to the stronger field inside the coil. So, other words, the moving iron is attracted into the other side. Where it is stronger field, magnetic stronger field is there, the moving iron attracted to the strong field side. The controlling torque is provided by springs. Hut gravity control can be used for panel type of instruments which are vertically mounted. Damping is provided by air friction with the help of light aluminum piston. Inside this one, you have to see the piston. That is the help of the light aluminum piston, which move in fixed chamber closed at one end, as shown in the figure, with the help of a vane. You can moving to the other direction. In a fixed sector shaped to chamber, as shown in a figure. One side is fixed, other side is moving to the particular dam vane. Okay. Next, repulsion type of the moving iron instrument measures both AC and DC currents as well as volts by using fixed coil to magnetize to soft iron vanes. One is fixed, one is moving with the identical polarities. You have to see the diagram. Now you can in between the south pole and north pole you have fixed one spindle. The resulting repulsion between these vanes created a torque, causing a pointer to move on a non-uniform scale. In the previous one is uniform scale, where it is discussed in the PMMC, but in the moving iron instruments, the uniform, non-uniform scales. These are the robust and inexpensive devices with air friction damping. How to find the deflection torque and given to the repulsion type? There is some smallest formula, TD equal to half I square dl beta by d theta. Here we have to find the kinetic equilibrium, final equilibrium position. Tc becomes Td and then kinetic energy equal to half L square dl by d theta. With this deflection, you have to find the theta, or the theta gives the how much deflection occurs into the repulsion type of instruments. Thank you.